Okay, reading guides for 5.1. It says finding rate of change using a table. So this is number 1. So the table shows the distance a band marches over time. Is the rate of change in distance with respect to time constant? What does the rate of change represent? Okay, so first off here, again, a formula for rate of change, distance over time in this case, or remember we would say that these are the x's, right? And these are the y's, so inputs and outputs. Dependent or independent and dependent, however you want to, whatever term you want to use there. So we know we can calculate that rate of change with a little subtraction fun. And so they've picked here two different points. They've picked the point 2, 520. So that's this one right here. And then they have also picked the point 1, 260. And then they subtracted them again. Those are plugged in over here. And so we end up with subtract, we get 260 over 1. It says it represents the distance a band marches per minute, right? So again, because it's feet over minute, right? 260 feet per minute. I don't know if that's fast or not. Anyway, in problem 1, do you get the same rate of change if you use non-consecutive rows of table? What that means is if I pick two other ones that aren't next to each other. So if I pick this one and then this one again, right? So let's do that here real quick. So that gives me 1040 minus 260 over 4 minus 1. You could reverse it too. You just would add a negative over a negative. And when you subtract, you get. So that gives you 780 over 3. And again, that obviously is going to reduce to 260 over 1. So yes, the whole point is if it's a line, right, a straight line, no curving or anything, the rate of change stays constant over the entire line. So that's a rule. Back to the idea of counting slope for number 2. So we have rise over run, so up 2 over 3, so we get 2/3. This one's going down, so again going down from left to right, it's going to be a negative slope, so this one goes down 4, you can count them with me, 1, 2, 3, 4, remember to count the hops, not the lines, so that's -4, so going down is negative, and going to the right 5 is right here. And again, we always count from left to right. Left to right. That way the negative ends up in the proper place, which is on top. So we want the slope of these two. I'll give you a second to count those, and then we'll pop those in. So this first one, we can see here that we go up 2 and over 1, 2, 3, 4, 5. So that's going to be our 2/5 up here. Second one, we can see that we're going to go down 2, right? So that's going to be -2, and we're going to go over 1, 2, 3, 4, 5, 6. So that's -2 over 6, which reduces to -1/3. So that's our second one there. And then our third, in part A of problem 2, pick 2 new points to find the slope. Did you get the same slope? So I don't know what 2 you picked, but I would certainly hope you did. Because you certainly should always get the same slope on a straight line, no matter what 2 points you pick. So now we're back to that concept of finding slope, just using the points instead of counting it. So we have -1, 0, and 3, -2. And our formula, y2 minus y1 over x2 minus x1. And you have to decide which one is going to be 0.1, which one's going to be 0.2. It doesn't really matter. But that helps you decide which is x1 and y1 and x2 and y2. In this case, they chose this as their 0.2 over here, the 3, -2. And so you can see the -2 there and the 3 there. And they chose this their 0.2, -1, 0, and here's the -1, and here's the 0. A little subtraction fun. -2 over 4 gives us -1/2 when we reduce. So here we have 2 points, and I went ahead and picked already my my 1s and my 2s, and I wrote the formula out for you. And again, if you need pause or whatever before you do this one. So let's write those in. So we know y2 is -1, and y1 is 3, and x2 is 4, and x1 is 1. So -1 minus 3 is -4, and 4 minus 1 is 3. So we're going to get -4/3. Yep, and according to the book, there it is, -4/3. Okay, so finding slope of horizontal and vertical lines. Our last got it here. What is the slope of each line? Now again, you can calculate it out. Absolutely. So I have a perfectly horizontal line. So I have the point, and you can pick any 2 points you want here. -3, 2, and 2, 2. And we plug them in. down here, and we calculate 0 over 5, which means that we end up with 0, because 0 divided by anything but 0 is 0. A perfectly vertical line, again 2 points there, -2, 1, -2, -2, plug them into our formula, and we end up with division by 0, right? Not possible. So that means that it's undefined. So again, perfectly horizontal 0, perfectly vertical undefined. So here we have the slope of 2 lines. So we have 4, -3, and 4, 2. And so let's start with that one. Again, our formula, we'll write that out here just a second. Okay, so again, a reminder of our formula right here, y2 minus y1 over x2 minus x1. And I went ahead and reversed up here my 1s and my 2s just to prove the point that it doesn't matter which order you select them in. You just have to, select them so you know which one's x1, which one's y1, that sort of thing. And I plugged them in. And over here on the left, we end up with 2 minus -3, which is 5, over 4 minus 4, which is 0, so that we say that's undefined. And on the other side, we have -3. It'll add up here, right? So anyway, so -3 plus 3, really, which is 0. -1 minus 5 is -6, which is 0. So there's your you got it for number 4. And again, one more look at this. Going up from left to right is a positive slope. Going down from left to right is a negative slope. Perfectly horizontal, 0. Perfectly vertical, undefined.